Okay, so three words here: work, energy, and power. Three different definitions, three different formulas, three different sets of units. Okay. Previous chapter was what? Force. In that, what type of force we learned about?
Centrifugal force.
Rotational force. We were not learning about linear force. Linear force was force is equal to mass into acceleration. That was not what we were talking about. We were talking about the rotational force. What is rotational force called? There's a word for rotational force. Moment of force. Moment of force is rotational force. And another word for rotational force, another word for moment of force is
Torque.
Torque.
torque. These people are thinking they're too smart. Torque. Okay. Torque is another word for rotational force. Okay. Now here we're studying about work. So let us see what is work. What does it mean when I say work has been done in physics? Okay, a force is applied and a displacement happens. Displacement means it moves away from its initial position. For example, if I push this phone, okay, the phone is stationary, and then I push the phone and the phone moved ahead. So that means I have done work, right? If I push the table and the table has moved forward, it means I've done work. If I push the wall and the wall doesn't move, it means I have not done work. Just so for work to be done, there has to be displacement. Okay, so the formula here for work is F into S, where F is force. That means you have to apply a force, and S is displacement. There has to be a displacement. Displacement means uh, the body has to move away from its initial position. That is displacement. Okay, if the body is staying in the same position, then displacement is zero. If the body is pushed and brought back to the starting point, then what is displacement? It's still zero because you're back to the starting point. Okay, in other words, if I carry a heavy box and I go one round around the ground and I come back to the starting point, no displacement, therefore no work is done. Okay, so there has to be a displacement. Now there are a few formulas for work. Before that, let's look at the unit for work. Okay, so let's look at the unit for force and displacement. What's the unit of force? What's the unit of force? Newton. What's the unit of displacement? Meter square. Displacement is in meter. How many meters away from the starting point are you? Right, the distance away from the starting point, that is meters. So force and displacement is Newton into meter. Does this look familiar to last chapter? In the last chapter we learned moment of force. What is moment of force formula? Force applied into the distance, the perpendicular distance. Remember, like if I'm opening a door, the moment of force felt on the door hinges, the force applied multiplied by the perpendicular distance from the hinge to where I'm applying the force, right? And we saw that if any of these two values increases, the moment of force will increase, right? Like if you push the door away from the pivot, then you're able to open the door and close the door easily, right? So what was the unit for moment of force? Huh? Force was Newton and distance meter. Here also Newton meter. Okay, so moment of force was also Newton meter. Work is also Newton meter. Okay, but for work we don't use Newton meter. We use joule. Joule is the same. 1 joule is 1 Newton meter. Okay, but instead of Newton meter we use the word joule. What about moment? For moment, is there any other word? Torque is another word, but is there any other unit? I mean, no, it is Newton meter only. Okay, for work the unit is joule. Okay, now the formulas. Wait, let's look at the textbook. Let's see what is here. Read the definition, Aman, for work. What is work?
Work is said to be done only when the force applied on the body makes the body move. For example, there is a displacement of the body.
IE stands for That is. Okay. Yeah. So what is it? Force has to be applied and the body should move. These are the two conditions for work to be done. Force and displacement. Here, is he doing any work? Clear? No. Why? So the wall is not moving. Okay, this is the proper definition for work done based on the formula. You want to read this?
The amount of work done by a force is equal to the product of the force and the displacement of the point of application of the force in the direction of force.
So a little more complicated formula, but it is talking about the, I mean, complicated definition, but it is still talking about the formula. It is a product of what? Product means multiplication. Product of what? Force and displacement. See, force and displacement. The displacement of the point of application of force in the direction of force. So that's again important. Now, suppose I'm applying force in a certain direction. Say force is applied in this direction. This is my force. And the body also moves in the same direction. That's displacement. If both are in the same direction, then this is the formula for work. Force into displacement. Both have to be in the same direction. Is there some case where you're applying force in a certain direction, but the object body is moving in another direction? Could that happen? It could happen. For example, that object that you're trying to move has wheels. Okay. So say this is a car. Okay, and the car can only go this way or this way because the wheels are pointed in that direction. Now, if I push the car right from behind, then it's like this. I'm applying the force in that direction, car is also moving in that direction. But what if there are 10 people pushing the car now, and the person standing on the side, he's not able to push in that same direction? Say he's pushing it a little diagonally like this. Does it mean that the car will go in that direction that he's pushing? No, the car will still go straight, right? You understand? Like this is the car, this table here, and I'm pushing from one diagonal from here. Does it mean that the car will move in that direction? No, it will still move in the direction at which the wheel is pointed. No. So there are cases like that where the force is in one direction and the displacement is in another direction. Okay. So
And
when,
what about the
huh?
revolving force?
What about
When you put a force on the doors revolve the
revolve?
doors.
So then if it comes back to its starting point, no work is done because there's no displacement. Okay, but if it moves a certain, suppose from here you revolved it and you moved it till here. Okay, the formula to calculate work is how much force you applied into the displacement. Which is the displacement? This distance, not the round curved direction. The shortest distance would be the displacement, right? So that's how you find the displacement. Okay, anyway, you don't have such cases in this chapter. What you have is like this, where the force is in a certain direction, straight line. Okay, we're talking about linear force, not curved forces here. So linear force in one direction, displacement in another direction. Then how do we calculate the work? So then what we need is we need the angle. We need this angle here between the force and the displacement. We'll call that angle theta. And then the formula for work will slightly be modified. It will be F into S into cos theta, where theta is the angle between what? The force and the displacement. Clear? But there are many more cases. This is two cases which we saw. Another case where the force might be perpendicular to the direction of force, where you're applying force like this, but the body is moving like this. So what will be the angle over here? It will be 90 degree. So if you apply the 90 degree in this formula, what is cos 90? We have learned the table, no? Cos 90 is
Zero.
it's zero. What meaning what? What's the work done? Work done will be zero in this case. See, if you're pushing an object and the body is moving perpendicular to the direction of force, then you're not doing any work. It's like a car again. You're pushing the car not from behind or front, you're pushing it from the door. What will happen? Will the car move in that direction? No. Car will move only in the direction at which the wheel is pointed. So that way you are not doing any work. Okay, the work done is 0. Actually, this is a common formula. You can use this one formula for everything. If you apply this formula in this first case, in the first case, what is the angle theta? Theta is 0 because both are in the same direction. There is no angle between force and displacement. So if I put cos 0 over here, what is cos 0? 1. So Fs into 1 means Fs only, no? See, the same formula, Fs cos theta, it changes into Fs when the theta is 0 degree. You notice that? And that same formula, if you put theta is equal to 90 degree, what does it become? Cos 0, cos 90 becomes 0 and W is equal to 0. Okay, so remember, this is your main formula, Fs cos theta, that can be applied for any angle, 90 degree or 0 degree or 30 degree or whatever angle. Anyway, 3 cases. When the force and displacement is in the same direction, formula is Fs. If there's any angle in between, then the formula W is equal to Fs cos theta. And if the angle is 90 degree, that is if the force is perpendicular to the direction of displacement, then the work done is 0. Okay. Now what if it's opposite? You're applying force in one certain direction, and the object is moving in the opposite direction. Then what's the work done? It's like, for example, a car is coming towards you, and you go in front of the car and you try to push it back, but the car is still coming forward. So what is the work done by you? It's not 0, it is minus. It's minus Fs. Okay, negative work. When the displacement is in the opposite direction of the force applied, then the work done is negative. Huh? Yeah, there are two people here. Okay, so this is the car. One person is pushing it forward, person is pushing it backwards. So say the person pushing forward, he's more stronger, and so the car is moving in that direction. So the second person here, B, he's doing negative work because he's doing work, but it is still moving against him. So it's like the work that he's doing is minus work, negative work. And the person A is more. Huh?
What will it do?
No, F into S, but minus. Minus F into S. Minus F into S. Okay, multiplication, only thing it will be negative. For example, the force he's applying is 10 Newton and the body is moving backwards by 5 meters. Then what's his work done?
minus 50.
If S is moving 5 meters backwards, so 5 into 10 into 5, 50, but minus 50 Newton meter or minus 50 Joule. Clear? One more last case where you're doing work upwards, you're climbing up a ladder or climbing up some stairs. Okay, that means you're doing work against gravity here. So gravity is trying to pull you down, but you're going against gravity. You're going upwards. So what is the work done over here in this case? So we are going to use the same formula Fs, but we are going to modify the formula. For F, we're using the formula for F. What is the formula of F? Mass into acceleration, right? But here we're going to take mass into acceleration due to gravity, that is G, because you're going against gravity and gravity is pulling you downwards. So you're going against acceleration due to gravity. You know what's acceleration due to gravity? What's the value of G? G has a fixed value on Earth.
9.8.
9.8 meter per second square. This is the acceleration due to gravity on Earth. Okay, that is G over here. And what is S? S was displacement. But when you're going up like this, upwards, we don't call this displacement. What do we call this? Height.
Right.
We call it height. How high you're traveling. How high up you climbed. So instead of S, we'll use the alphabet H. So the formula for W is what? mgh. You've heard this formula before? Potential energy, 9th standard, I think you had. Kinetic energy, potential energy. So this was the formula for potential energy also. We'll talk about that later. But right now, W is equal to mgh. When do we use this formula? If you're going against gravity, okay? Climbing up. If your height is changing. You notice it's the same thing actually. mgh is fs. But instead of F, we're using mg. And instead of S, we're using H. Okay. So
Unless the gravity same on every part of the earth.
what is the
Is
gravity same?
gravity? Yeah.
No. So if you see the Earth is not a perfect sphere. The Earth is more wider at the equator. Okay. So the Earth is slightly like this. It's wider at the equator and lesser. It's flattened like this. Okay. So since the equator is more away from the center of the Earth, the gravity at the equator is lesser, and the gravity at the poles is slightly more. Okay, so this 9.8 is not even throughout. At the equator, the number is actually 9.82 or something like that, little bit more. And at the poles, it's slightly less. It's around 9.79 or something like that. Okay, so the average acceleration due to gravity on Earth is 9.8. In fact, that also we don't use. We use 10 generally, right? We just round it up to 10 and we use it just for calculation sake to be easier. Okay, all right. So we have seen how many formulas for work done. First one is Fs, that is if both are in the same direction. Second is Fs cos theta, that's if there's an angle. Third is if they're perpendicular to each other, then 0. Then fourth is if the displacement is opposite to the direction of force, then minus Fs. And then the last one was if you're doing work against gravity, then mgh. All of these have the same unit for work. What's the unit of work? Joule. Whichever formula you use, the unit of work is the same. That is joule. Okay. All right. Write this much down. Done writing, everyone?
Yes, sir.
Okay, let's just go through the textbook now and see what all is there. Okay, so the formulas. So first formula we saw was W is equal to F into S. Second formula we saw when there's a different theta, if there's a theta in between, right? So force is in one direction, displacement is in another direction. So that time the formula is Fs cos theta. Okay, there's a little more. When you go home, you have to read this and study it. Okay, there are two ways to get the formula Fs cos theta. So that's what they're showing here. By finding the component of displacement along the force. I'll explain that in the next class. And second is by finding the component of force along the displacement. Whatever it is, you will get the same formula F into S cos theta. Then, what's the next one? Next one, they're showing against gravity. No, they're showing special cases. That is, work done is positive, work done is negative, work done is 0. Then mgh. Now, conditions for work done by force to be 0. When will the force done be 0? First is when there is no displacement. Also, when the displacement is normal to the direction of force. We saw that no, when the theta is 90 degree, that time also there is no work done. And then there are units. The bigger unit is joule, and there's a smaller unit called erg. That also we'll see that in the next class. Okay, how to convert from the bigger unit to the smaller. So learn this much clearly. Do your maths homework and learn physics for tomorrow. Okay, everyone. I'll see you in the next class.
Bye, sir.
Everyone. Okay, so yesterday in physics, we saw all the formulas for physics. I mean, formulas for work. Okay, we saw that if force is applied in a certain direction and the displacement is also in the same direction, then you have the formula F into S. If there's an angle in between, then Fs cos theta. If the angle is 90 degrees, then the work done is zero. If the displacement is in the opposite direction to the force, then minus F into S. And if the force is applied against gravity, then F into, but we don't use F into S, we use mgh. Okay, you need to be sure of the units now. All of these, let's talk about the units. Now, F and S and work, we already spoke about the units. Force, the unit of force is Newton. Displacement is meter, and work is joule. So all of this have the same thing. Now, when we come to this second formula, W is equal to mgh, what is the unit for m, g, and h? What's the unit of m? See, if you're using F into S, then it is Newton into meter, right? But if you're using the formula mgh, then what is the unit for m? Kg. Mass, no? G? What is G? Yes. What does G stand for? Acceleration due to gravity. Don't say gravity, it's acceleration due to gravity. Okay. The unit is any unit for acceleration. Meter per second square. And h, what is h? Height. Height is same as s, which is displacement. So the unit is meter. Okay. So these are all the units: kg, meter per second square into meter. If we are using these units, then what would be the unit for work? If you applied exactly these units, it would be kg meter per second square into meter, which means meter square per second square. This would be the actual unit if we were using all these units, right? But we don't use all this. What is the unit for work? Joule. Okay. All right. So these are all the formulas for work. Now, this second formula, which is W is equal to Fs cos theta, there are two ways to derive this formula. Okay. So we will see that now. Just draw this triangle. Just draw a triangle. I will tell you what values to put. I'll just come in a minute. Sorry. Okay, here you see this triangle. Now, what is this triangle drawn here for? So here they're showing that force is applied in this particular direction. That is along the surface. Okay. But the object is not moving in this direction. How is the object moving? Yeah, it's going in that direction of this arrow. So this is your displacement, which is in that particular angle, and the force is flat like this. So the angle between the force and the displacement is over here, which is theta. Correct. Now, when we're applying the values in this formula, W is equal to Fs, your F should be in the direction of the force, which means you need this value for S here, the base, not the hypotenuse. But here S is the hypotenuse. So we need to find the base. So how do we find this base? Do you remember any formula in maths where we have the hypotenuse and the angle and we can find the base or the adjacent? This is what we used to call this adjacent, right? Was that? Pythagoras theorem is if you have two sides, if you have both the sides, and then you can find the adjacent. Here it's not like that. Here it is, you have only one side and one angle. Huh? See, you have hypotenuse and adjacent. I'll remind you. Do you all remember some of our children are having trouble over algebra?
Yeah.
Those are the formulas you have to use. Anna, do you know that? Some of our children are having trouble over algebra. Have you heard of that? No. We learned that in 9th standard. Okay. So in that formulas, we have cos theta formula. What is cos theta formula? Children are having. Children adjacent upon hypotenuse. See, this is a formula which has adjacent and hypotenuse. You understand? So to find the adjacent, we need to make the adjacent the subject over here. First, let's substitute the values. So cos theta is equal to adjacent is what we have to find upon hypotenuse. Hypotenuse is your S. So if we take S on that side, we will get the formula for adjacent. Adjacent is what? S into cos theta. Right? If you take S on that side. So that is the value of this adjacent. It is S cos theta. You understand how we got this? So now when we apply the value in this formula, uh, F is F itself, and the displacement is S cos theta. That's why we have S cos theta here. Understood how we got this formula now, everyone?
Yeah.
We can't take Fs. Why? Because F and S are not in the same direction. So we are finding S in the same direction as of the force. And then we get this value S cos theta. Okay. So that's how we get this, derive this formula W is equal to F into S cos theta. Okay. Now they have done it in two ways. One is by finding the component of displacement along the force. Component of displacement means the value for the displacement in the direction of force. That's what we did right now. We found the component of displacement in which direction? In the direction of force. Okay, that's what we did. The second way to do this is by finding the component of force along the displacement. Means now the force is not in this direction. Anyway, we'll see that after this. Okay, now you write down this and yeah, write down this much. This is the derivation for W is equal to F into S cos theta. Okay, done? So right now what we did is we found the displacement, sorry, we found the component of displacement in the direction of force, which means everything is in this horizontal direction. Since S was diagonal, we found S in the horizontal direction. Now what we're going to do is we're going to change force in the direction of the displacement. We're going to change the component of force in the direction of displacement. That's the second method. You have tried the heading, okay? So the first one, the heading was by finding here, by finding component of displacement along the force. Okay, in the second one, what we're going to do, now we're going to change the direction of force into the same direction as that of the displacement. So we need to make force how? Like this. Correct? We need to change the force from here to here. So here we need to make a triangle. This is the direction of force. We have to change it into, we need to find this value. So we make another triangle over here. Right now we have force in the horizontal direction. Okay, we can call that the base. Okay, this is theta. So that same theta will be here also, vertically opposite angles, right? So we have the base. The base is F. What we need to find is the hypotenuse. We have to find this hypotenuse. So again, we'll use the same formula. This is your adjacent. This is your hypotenuse. So which formula we're going to use is cos theta. Cos theta is equal to adjacent upon hypotenuse. Okay. So here we have adjacent as F. So cos theta is equal to F upon. Okay, this will not work. We have to change, make a change here. Okay. So what I've done is I've taken the 90 degree over here. This is where I've taken the 90 degree, right? If I do this, then I'm getting hypotenuse is equal to what? Interchange this, I'm getting F upon cos theta. Okay. So we're not going to do it this way. We have to make a small change. So what I did is not the right one. We have to make the hypotenuse. Okay, look, the 90 degree has to be over here. Look at the diagram in the book. It has to be like this. So this has to be a 90 degree. Okay. So if this is your 90 degree, then this side here, what is it called? This will be the adjacent. And here on top, there will be hypotenuse. Okay. So let's make the change here. This is your hypotenuse and here down we have the adjacent. Okay. All right. Now applying the values in the formula, cos theta is equal to adjacent upon hypotenuse. So we have to find adjacent, right? We have to find adjacent. So adjacent upon, what is hypotenuse? Hypotenuse is f. So now make the adjacent the subject. So adjacent will be what? Multiply f into cos theta. So f into cos theta. So that's the value here. This adjacent here is what? F into cos theta. Okay. So now coming back to our formula, W is equal to force into the displacement. Here we are changing force in the direction of force in which direction? Direction of displacement. Force in the direction of displacement into S. So force in the direction of displacement is what? F into S cos theta. So F into cos theta into S. So put that cos theta at the end. So we have Fs cos theta. You understand? So whichever formula, whichever method you use, whether you're finding force in the direction of displacement or displacement in the direction of force, we are still getting the same formula, which is Fs cos theta. Got it, everyone? Okay. So write the heading here for finding the component of force along the displacement. And do this. All right. Yes, finish writing this, and we'll continue. Even you're going anywhere during this holidays? When? Oh, tonight you're going. And when you're coming back? 12th. Which 12th? June? May 12th. Okay, 12 days. Join from there, okay? Don't want to miss anything. Okay, shall we move on? Now we are going to talk about the different units of work. What is the unit of work, Aman? Joule. Don't forget that. The unit of work, we're seeing only that till now. The unit of work is joule. Okay, now this is the SI unit, the standard unit. Now, if you want to go bigger, then we can just add the words kilo, mega, giga in front of it. Okay, like kilojoule is how much? Kilo means what?
1,000.
1,000 or 10 raised to 3, right? Kilo is 10 raised to 3. So kilojoule means 1,000 joule. Then bigger than kilo is what? Mega. How much is mega?
10 raised to 6.
10 raised to 6. You keep adding 3 more zeros. And then bigger than this is?
10 raised to 9.
Yeah, that is what? Giga. 10 raised to 9. And then above giga will be what?
10 raised to 12.
What is it? Huh? Not tetra. Tera. Terabyte. You know, we say no phones and memory cards and all that. Gigabyte, megabyte. Yeah, so these are the bigger units. Now, when you go smaller, you can say million, micro, and all that. But there is another standard unit, the CGS unit, which is called erg. Okay, so the SI unit was joule, which is J, capital J, because it's named after a person. And the CGS unit is erg, not named after a person. So it is erg only. ERG, that's the unit. No short form, no full form. It is erg. Okay, now how much is the conversion? What is the conversion of 1 joule, you know? 1 joule,
10 raised to 7 or
10 raised to 7 erg. Okay, so that is a conversion. You have to write this and remember it. But we're going to see its derivation. Okay, they will ask you derivation. Derive the SI unit and CGS unit for work. Okay, so how do we derive any unit? You need to write the formula. The formula for work is F into S. Right? And then under this, you write the respective units. For work, you will write joule. So put 1 joule. And for force, 1 Newton into distances, 1 meter. Okay, so 1 joule is 1 Newton into 1 meter. And then you convert all of them to their smaller units. So what is the smaller unit for Newton?
Dyne.
Dyne. Okay, for force, the SI unit is Newton and the CGS unit is dyne. So 1 Newton is how many dyne now? 1 Newton is 10 raised
10
to
raised to 5.
10
5.
raised to 5.
When did you learn this? I mean, don't look and tell, but when did we learn this? When was it taught? I think it's ninth. Okay, this conversion of force, the units of force was in ninth. All right, so 1 Newton is 10 raised to 5 dyne. And 1 meter is what? Centimeter. How many centimeters? 100. 100, if you write it as powers, that is 10 raised to 2 centimeters. So now 10 raised to 5 into 10 raised to 2 is how much? 10 raised to 7. Remember the chapter exponents in math. You have to add the powers, no? 5 plus 2, 10. So that is 10 raised to 7 dyne centimeter first we will write. And this another word for dyne centimeter is erg. That's how we have 10 raised to 7 erg. Therefore, 1 joule 10 raised to 7 erg. Write the heading as relationship between joule and erg.
But Anna, why did we take 100 centimeters?
Because 1 meter is 100 centimeters. We're converting each of these units to their smaller units. We converted Newton to dyne and meter to centimeter. Okay, right. First, we need to see power also today. Okay, so we finished seeing work. Example of work we saw was doing something, doing some work, like moving something from one place to another place. That was considered work, right? If I'm telling you to push this table, if you move it from one place to another place, it means you have done work. Okay, now what is power? Hmm? Okay, power, the formula, let's see first. The formula for power is work done upon time. So we're using work that we saw before, but just upon time. It means how fast you're able to do that work. Right? Suppose I give Aman and Ahmed a work to do. I give two big boxes, same weight. Okay, but Ahmed is able to push it in 1 minute, and Aman takes only half a minute to push it. What does it mean? You both did the same work. You moved it from the same place to the same place. But Aman was able to do it in lesser time. What does it mean? He has more power, not energy.
Power.
Okay, energy is same. Both of you did the same energy, same work. But what is different is power. So power is inversely proportional to time. You know, anything in the denominator is inversely proportional, which means if you do the work in a lesser time, it means you have more power. If you take more time to do the work, that means you have lesser power. Okay, so that's the only difference between power and work. It's just how much time you take to do that work. Okay, all right. Now, what is the unit for power? The unit for power is watt. Now, if you look at the formula, the unit would be what? Would be question mark what? This work is all W's, okay? It'll confuse you. W here is work. The unit for work is joule and the unit for time is second. So looking at the formula, unit for power would be joule per second. Right? This is what the unit would have been or actually is looking at the formula. But instead of joule per second, they named it after a person, watt. Okay. They've done this for so many units, no? Like instead of using one very big unit, they have replaced it with another unit. Okay, so that's what the formula is. Now, what does power depend upon once again? Power depends on work done and time taken to do that. How is work related to power? Directly proportional. The more work you do, it means the more power you have. How is time related to power? Inversely proportional. Now, looking at the units are very simple over here. The bigger units are kilowatt, megawatt, gigawatt, and so on. And the smaller units are milliwatt, microwatt. Okay, so just you can, we have already written what is mega, giga, and all that. What is milli now? Milli is 10 raised to
-3.
That means you divide with 1000. It's a smaller unit. And then again you divide with one more 1000. That means 10 raised to minus 6 would be, sorry, minus 6 would be what? Micro. If you again divide it by 1000, so it becomes 10 raised to minus 9. What is that? Nano. Okay. So you don't have nano, that's too small, but we have milli and micro for smaller units. And you have one more unit for power, which is horsepower. Okay. Where have you heard about horsepower? Okay. Use cars, bikes, they use horsepower, but that's a slightly different horsepower. It's called BHP, brake horsepower. So that is not exactly this horsepower. Okay. Slightly different. But motors, like if you have pump to pump water, they buy the motor based on the horsepower. It's a 2 horsepower motor, 5 horsepower motor. That's how they say it. There they actually mean this horsepower only. Okay. So this is the relation, the conversion between horsepower and watt. 1 horsepower is 746 watt. You have to learn and remember this conversion. 1 horsepower is equal to 746 watt.
Now, when we went to buy a water motor, they were selling it in tons, like 0.5 ton, then 1 ton.
That is for AC.
No, the water motor.
Water motor also is in ton.
Yeah.
Okay, I'll just confirm with that. Like what is the conversion about ton, and I'll see that and let you know. You also check on Google, all of you, what is ton? Like because when you buy ACs on water motors, sometimes instead of horsepower or watt, they say tons.
1 ton is 20.
Yeah, but they're not meaning that ton. See, 1 ton is 1000 kg. We know that, right? But when you buy a device like this which runs on electricity, you don't care about its weight. So that 1 ton doesn't mean 1000 kg. That is a different way of representing the power consumption. Okay. Yeah, but motors I have seen is always in horsepower. Okay, if you have a well, they use a 0.5 watt or a 1 watt, sorry, 0.5 horsepower or 1 horsepower or 1.5 maximum. But if you have a bore well, very deep, you have to pull the water out of the earth, right? For that, they use a 5 horsepower motor because it's a very, you have to pull the water from so deep depth, right? Okay. All right. And there's a differences here between work and power. Work is just the product of force and displacement. But power is how fast you're able to do that work. Does work depend on time? Work doesn't depend on how much time you take. You did the work, you did the work. But power depends on time, how fast you're able to do that work. The SI unit for work is joule, and the SI unit for power is watt. Okay. So with that, we are done with power. Okay. Next class, we will be seeing what is energy. Okay. We'll end with this.
No,
Yeah.
1 ton is approximately equal to 3,500 kilowatts. Sorry, watts.
Watts. Oh, okay. So that's another conversion. 1 ton, 3,500 watts. Okay, good. So now you know that. So yeah, we will see more on watts and what does it mean of power. Okay, in terms of electricity also, and in not electricity also. All right, then we'll end. This one? Oh, that's on the other page. Okay, the ones online you can leave. I'll see you tomorrow. Bye. All right, so we have seen work. What was the formula for work? Work was equal to work is equal to work over time. Work is equal to force into displacement, and then Fs cos theta and mgh and minus Fs. We've seen so many formulas for work, right? Then the second topic was power. Power is this work just divided by time. So the definition for power is what? The rate of doing work. Rate means in how much time you're doing work. Okay, that would be the definition for power. What is that? The rate of doing work. Now the third topic is energy. Now energy is considered as work done only. because only if you have energy you can do work, right? So energy and work, they have the same units, they have same formula, everything is there. Just the definition is a little different. See the definition. What is energy? The energy of a body is its capacity to do work. So if I say, okay, Beryl has energy, how do I know Beryl has energy? Because she can do work. Suppose Leah cannot do work, then I cannot say Leah has energy, right? If you have, if you can do work, it means you have energy. If you cannot do work, it means you don't have energy or you're lazy, right? But in physics, how it is? If you have energy, you can do work. Okay, so that's the definition. Work and energy are scalar quantities. Scalar quantity means it has nothing to do with direction. You know, scalar and vector quantities. Vector quantities means it has magnitude and direction. Scalar quantity only has magnitude, means it has some value. It has no direction. Now, the units of energy, there are little more extra units. Okay. Now, one of the first unit is same like work done, that is joule. And 1 joule is equal to how much? 10 raised to 7 erg. We have already seen that in the work part. Now, the bigger, okay, now to see the other units, we need to look at the formula for, or look at any formula which has work. So, which formula has work? Or what's the formula for work? Work is equal to F into S. But we're not going to look at that formula. We're going to look at another formula which has work. Which is that formula? Power. Yes. So power's formula is what? Work upon time. But here we'll, instead of work, we will write energy because we are talking about energy. Okay. So energy divided by time. Now from this formula, we will make energy the subject. If you make energy the subject, what is the formula?
Power into time.
Into time. Okay. Now let us see what were the units that we used to get the unit for power. What's the unit for power? Watt. WATT. How did we get this watt? What had to be the unit for energy and time? Joule and second. If energy is in joule and time is in second, then power is in watt. Correct? I'm writing the same units in this formula now. So if power is watt and time is second, then energy is what? Joule. I'm just rearranging it. Listen very carefully. Okay. We're going to modify it now. The same formula. I just made energy the subject and I put the units over there. Joule is equal to, what is W here? Watt into second. Okay. But now if you take power as the same watt and time as hours, now can we call energy as joule? No. Energy, the unit of energy is joule only when power is in watt and time is in second. If time is in hours, then the unit for energy will not be joule, it will be watt hour. See, W into H, WH. Watt hour. Watt hour. Correct? So these are two units for energy. The first unit was joule, which is a standard unit. The second unit is watt hour. When do we use joule? When the time is in seconds. When do we use watt hour? When the time is in hours. Okay. All right. So which is a bigger unit here now, joule or watt hour? Watt hour is bigger because you're calculating the energy consumed by any appliance. Say for in your house you have a bulb. It is calculating the energy consumed by that bulb in 1 hour. Understood? Joule is what? It is the energy consumed by the bulb in 1 second. That's too small to calculate. We're using bulbs and lights and fans for a whole month and years. What's the point of calculating in 1 second how much is used? It's not practical. You understand? So we are using a bigger unit for energy, that is watt hour. Clear? Now watt hour is also small because we don't use it for just hours. We're using it for how much? Months, and the lights are being used for months and longer time. So this value will be very big. Okay. So we make a small modification. Instead of watt hour, we use kilowatt hour. Kilowatt hour. Kilo is what? Kilo means the power into time divided by 1000. If you divide this watt hour with 1000, you will get kilowatt hour. Or let me just write here watt hour divided by 1000. Watt hour, if you divide by 1000, you're converting it into kilowatt hour. Okay. Now, this is the unit that is more commonly used when we're calculating electricity bill in houses and all that. Okay. You will be doing this not in this chapter. We'll be finding out electricity bill in another chapter later on, which is called electrical. What's the chapter in your book? Go to your index. Household circuits? No, before that. Electricity only. What's the chapter before that? Yeah, in that current electricity, you have numericals of finding what is the electricity consumed in a house. So that time you'll be using this formula. What is this formula? Energy is equal to power into time divided by 1000. This is the formula. Okay, a quick revision of this formula. We have seen three different units. If power is in watt and time is in second, then what's the unit of energy? Joule. If power is in watt and time is in hour, then what's the unit of energy? Watt hour. And if you divide that thing with 1000, then the unit is kilowatt hour. Is that clear? So kilowatt hour is what we use for calculating electricity. Now they have also written the conversion between joule and watt hour. Okay. See, joule is for 1 second, no? And watt hour is for 1 hour. Okay. So if we convert the second to hour, how many seconds are there in 1 hour? Huh? 60 into 60. In 1 minute, there's 60 seconds. In 1 hour, there is 60 into 60. That is 3600.
1200.
3600.
Yes.
Correct? 60 into 60. Yeah. So there is 3600 joules in 1 watt hour. Understand that conversion? 1 watt hour is equal to 3600 joules. Yes or no? You all get that? Yes, this is the conversion between watt hour and joules. So what will be 1 kilowatt hour then? 3600 and put 3 more zeros. Right? Because kilo is 1000, right? You have to multiply with 1000. So 1 kilowatt hour is a very big number. Instead of writing it like that, we can write it as 3.6 into 10 raised to how much? 1, 2, 3, 4, 5, 6. 10 raised to 6 joule. Okay, so 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. And 1 watt hour is how much? 3600. That means 3.6 into 10 raised to how much? 10 raised to 3, no? Hey, are you all getting or not? Should get this fast. You're just converting these numbers into the standard values. Standard value, that is 1 watt hour is equal to 3.6 into 10 raised to 3 joules, right? See, the point is here, 1, 2, 3 places. That's why 10 raised to 3. Here, if you're bringing the point to 3.6, you're moving the point 6 places back. That's why 10 raised to 6. Okay, write down this much. This is the derivation, not derivation. This is the explanation for what is 1 kilowatt hour. See this 3600 joule or 3.6 into 10 raised to 3 joule. What is 10 raised to 3? We have those prefixes, no, kilo, mega, and all that. What is 10 raised to 3? Kilo. So 3.6 into 10 raised to 3 joules can be written as what? 3.6 kilojoule. Because 10 raised to 3 is kilo. Understand? And what is 10 raised to 6? Huh? Mega.
Mega.
So this 1 kilowatt hour can be written as 3.6 megajoule. That's clear? Note that down. Okay, so what we have seen in all of this is joule is a very tiny unit of energy. It's very small. Watt hour is much bigger, and then kilowatt hour is much more bigger, right? So in all of this, the smallest unit was what? Joule. Okay. We have another unit called calorie. Now, calorie is also a small unit, but not as small as joule. Joule is still smaller. Okay. Now, 1 calorie. Calorie is what? 1 calorie is the heat energy required in raising the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. You can take any temperature, but it is 1 degree. The amount of heat energy required to increase the temperature of 1 gram of water by 1 degree Celsius. That is 1 calorie. Understood the concept? If I take 1 gram of water, how much do you think is 1 gram of water? Few drops. Okay. And say that one's temperature is 20 degrees Celsius. Now, if I put some heat from down, and if the temperature goes up to 21 degrees Celsius, that amount of heat that was given is 1 calorie. Understood what's 1 calorie? It is the amount of heat energy required for what?
To increase the temperature.
To increase the temperature of 1 gram of water. By how much? By 1 degree Celsius.
So if we drink that water, we will gain 1 calorie.
If we drink that water. Yeah, 1 calorie is a... See, what happens? Temperature and all will change. But yeah, I'll explain that to you. Just rejoin the meeting, you all. Then we will talk about what is the meaning of this 1 calorie. Yes, so how much is 1 calorie? Now, which is a smaller unit, joule or calorie? Joule is still smaller, okay? So calorie, 1 calorie is 4.18 joules. So which is a smaller unit? Joule. Because in 1 calorie, there are 4 joules. So joules are smaller, no? Aman. That's why 4 joules can fit in 1 calorie, okay? Yes, but it's not too big. Calorie also is small only because joule is small and 4 joules make 1 calorie. That is also very small. So we don't use calorie, we use kilocalorie. So 1 kilocalorie means how much? Come on, tell me. Kilocalorie means 1000 calorie. Okay. Now, this is the unit that we use when we buy foods and we eat. It's written outside, no, 500 calories. What they actually mean is 100 kilocalories. Even though they call it calorie, it's actually kilocalories because calorie is too small to be used as the unit. Okay. So we always convert calorie into kilocalorie. And what do we call it? Calorie. It's a little confusing. What is
How
that?
does body fat increase due to calorie?
Yeah, that's what I said. No, if you take in more calories than you are using, the calories will get converted into fat and just get stored in your body. Okay. All right. So here, 1 calorie is 4.18 joules. So 1 kilocalorie will be how much in joules? You see, how many joules? 1 calorie is 4.18 joules. So 1 kilocalorie will be how many joules?
We have to just remove the point.
4180.
Yeah, 4180 into 1000, no? Kilocalories.
That is it, but I was confused.
Yeah, into 1000 you have to do it. Just move the point 3 places to the right. Okay. All right. So these are three conversions again for calorie. Okay. So we're seeing all different units for energy. First we saw joule. The first unit we saw was joule. The second unit we saw is what? Second unit is water. Water. And the third unit is kilowatt hour. Okay, that is also one unit. And then the next unit we saw, fourth is calorie. And then the last unit is electron volt, EV. Okay. Now, electron volt is a smaller unit than joule. It's very, very small. It is the amount of energy that you see in atoms. So atoms are very small. So that energy is also very small. Okay, let's read the definition. The energy transfer in case of atomic particles is very small. So it is measured in electron volt. Okay, so what is this? Energy transfer in case of atomic particles. Like see electrons, no? They have energy. Correct. Electrons, they have energy. That's why they are revolving around the atom. Sorry, around the nucleus. So the amount of energy present in electrons is calculated in this unit, electron volt. Okay. So what is electron volt? Let's see. 1 electron volt is the energy gained by an electron when it is accelerated through a potential difference of 1 volt. So when you give a voltage of 1 volt, the electron is accelerated. It increases its speed. So it gains energy. So the amount of energy it gains is 1 electron volt. Okay. We don't use this much. You just have to remember the conversion. Okay. So 1 electron volt is the charge on an electron into 1 volt. The charge on an electron is 1.6 and 10 raised to minus 19 coulomb. You remember this number? Seeing it anywhere?
Yes, in electricity chapter.
We had it in chemistry, no? I think when we chemistry, when you study about electrons, protons, and neutrons, we learn this as the charge. This is the charge of an electron. This is also the charge of a proton, right? Because proton and electron, they have the same charge, right?
Yeah.
So 2.6 into 10 raised to minus 19 coulomb is the charge on an electron. In fact, it is negative actually, because electrons are negatively charged. Okay, but they're just taking it as the absolute value. So that coulomb into volt becomes joule. Okay. Yeah, there is a formula for, but let's just
Anna,
hmm.
Anna, behind the charge also they write EV. So this EV they mean electron volt.
No, that EV is electric vehicle. Electric vehicle. That's the full form of that EV. Okay. Okay. So one EV is equal to 1.6 into 10 raised to minus 19 joule. Okay. This is the conversion of electron volt. Okay. Write down whatever you have not written down. You done? Now here you have the differences between energy and power. Not work. Work was the first. Second was power. Third is energy. The difference between power and energy. Before this, we also saw the difference between work and power. Energy and power also will be the same only because work and energy is the same thing, right? Okay, so let's see the definitions. Aman, read definition of energy.
Energy of the body in its
Capacity to do work. What is power, Beryl?
Power of the source is the rate at which energy is supplied.
Okay, so they're talking about power in as a source also and also as how much is being consumed. So if you're talking about power as a source, so what is that? It is the rate at which energy is supplied. How fast energy is being supplied. If you're talking of power as being consumed, then that is how fast energy is being used up. Okay. Now, yeah. Basically, power is related to how much time it takes for the energy to be either used up or produced. If you're talking about battery, what is a battery doing to energy? Producing or consuming? Battery is producing, right? What about the remote? Is it producing power or using up power? It's using up. No, we are putting batteries inside. No, so the remote is using up that power, right? So power is what? If it's a source, like if it's a battery, we talk about how fast energy is being supplied. If it's a device like a remote, we talk about the rate at which energy is being consumed. How fast energy is being consumed. Basically, there is time in it. Next, energy does not depend on time. Power depends on time. That is the next difference. And last is the unit. Unit of energy, joule, and unit of power, watt. Okay. All right. So that is the A part of the chapter. Okay. We'll do some numericals now from this chapter. You have all the formulas. Basically, how many formulas are there? How many formulas for work you had? Fs, Fs cos theta, mgh, minus Fs, all of that. That is the unit for the formulas for work. Then for power, you only had one formula. What is that? Work upon time. And then for energy, no new formula. Same formula that you use for work only. That is a formula for energy. Okay. All right. So let us look at some questions. Let's do question number 1 and then we'll do number 2. Amit, your brother looks like you only. Amit is busy. Okay, here, question number 1. A body, when acted upon by a force of 10 kgf, gets displaced by 0.5 meters. Calculate the work done by the force when the displacement is 1 in the direction of force, second at an angle of 60 degree with the force, and normal to the force. So they're asking work done in 3 different cases. Okay, so what all is given? Tell me. What is 10 kgf? Force. Yeah, force or weight. So the force is 10 kgf, but kgf is not the standard unit for force. What's the standard unit for force? Newton. So how do you convert this into Newton? Into 9.8. That is acceleration due to gravity. See, once again, the formula for force is mass into acceleration. And the formula for weight is m into g. Force is written as weight. Acceleration is written as acceleration due to gravity. Okay. Now mass, what's the unit of mass? The unit of mass is kg. Okay. And the unit for acceleration due to gravity is meter per second square. Right. Now, sometimes when we convert mass into weight, we don't change anything. We just, instead of kg, we write kgf. Right. I think I should remind you of this. Most if you look confused, see, you have mass and you have weight, which is a force exerted by you towards the ground. Okay. What is the unit for mass?
kg,
Kg. What is the unit for force?
Newton,
Newton. Then what is kgf? Kgf is the unit of force.
force,
Okay. The thing about kgf is kg and kgf have the same values. Aman, what's your weight?
55.
Okay, let's say 50 kg. If you're 50 kg, your mass, your weight is 50 kgf. Kg and kgf have the same values. Kg is the unit for mass and kgf is the unit for weight. Both have the same values. Okay. Okay. So now if you're converting kg into Newton, look at this formula here. Kg into Newton. The actual unit for force is Newton, right? So how do you convert kg into Newton? Concentrate here. You have to multiply kg into what? You have to multiply the kg. Kg means mass. You have to multiply mass with g. Then only you'll get your weight in Newton. These are all very simple things. These are not taught in 10th standard. This is smaller, 8th and 9th standard portion. Here, answer me and be clear with these things. Okay. do one thing. Let's forget about this for now. Okay. Look at kg. Look at Newton. Kg is unit for what?
Mass.
Mass. Newton is unit for
Force.
force or weight.
Force.
So if you want to find Newton, we have to do kg into meter per second square. That means mass into acceleration due to gravity. What is acceleration due to gravity? How much is it? It's 10. 9.8 approximately taken as 10. If you look at this question here, they've given g. How much is g? 10. Unit is different. That's another unit for acceleration due to gravity. Okay. Newton per kg. But don't worry about that. It's either 10 Newton per kg or 10 meter per second square. Yeah. So if you multiply this kg into 10, we will get the Newton. So what is your weight now? If it's 50 kg, in Newton, how much is it? Huh? 500 Newton. Right, because you're multiplying your mass into 10. Okay. Clear, everyone? Now let me remove this. Okay. All right. So 500 Newton is your mass. It is also 50 kgf. So kg and kgf have the same values. Clear, everyone? Now in this question, they have given the force as kgf. Is that wrong? No, the unit of force is kgf. Correct. But you need to convert that into Newton. How do you convert into Newton? Into 10. Into 10. That 10 is the acceleration due to gravity. And so we are getting the force as 100 Newton. Is that clear, everyone? Before you do the sum, please write this much. Write this part. And I'm not going to explain this again. I've explained this many, many times. Mass and weight. Okay, the difference between mass and weight. After that, you write down all the values given. Try solving it. I'll just come in 2 minutes. Anyone got anything? Yeah. So force is 100 Newton. Displacement is 0.5 meters. And they're asking you what is the work done? First case, when the direction is in the same, when the displacement is in the direction of force. So what's the formula for work done?
Work is equal to F into S.
Aman, where are you, Aman? F into S, when the direction is in the same as that of force. So that is 100 into 0.5. Very direct, not even confusing. It's absolutely direct. So that is 50 joules. 0.5 means half. So what is half of 100? 50. Second case, there's an angle now, 60. So which formula will we use? Fs, Aman? Fs cos theta. So put the theta over there, find that. Do third one also, all are easy. Everyone done? Normal means 90 degrees. The word normal means 90 degrees. Okay, we have seen this word in reflection. When you see a plane surface, when we say normal, this is a normal. Do you remember this, everyone? If this is the incident ray and the ray reflects and goes this way, huh? What is this called? Normal, no? So normal is a line that is perpendicular to anything. Clear? So here they're saying what? The displacement is normal to the force. That means they're 90 degrees to each other. Displacement, the body is moving 90 degrees to the force. So tell me, what's the work done? Zero. Zero, right? Because 90 degrees. Theta is 90. Cos theta is how much? You all are not studying at all, okay? Only Beryl is answering the website. We saw object when the displacement is perpendicular to the direction of force, there is no work done. I give you example of car also pushing from the door. Car doesn't move in that direction. To the next question also. Next one is against gravity. That's the only hint I'm going to give you. So if how do you calculate work done against gravity? I heard you. Yeah, I didn't want others to hear, but all of you are not studying. You have to study the formulas. 2 days ago, we gave all the formulas. Okay. So the formula for against gravity was mgh. Use that formula. First question is force. What's the formula for force? Force is mass into acceleration. So force against gravity will be mass into acceleration due to gravity. Second question is work done against the force of gravity. So that is mgh, and power spent. Power is equal to work done upon time. Or direct formula. Okay, do.
Got all three.
Got all three? Okay. Everyone got all three? Tell me if when you get.
Didn't get the first one, second question at an angle of 60.
Cos 60 is how much? Cos 60 is 1 by 2.
By 2.
So replace, put instead of cos 60, put the value 1 by 2. Anyone has any doubt? Please ask. If you didn't get, ask. If you got, your tuition is over. I'll give you homework. You have the same questions in your book? Check if 1 and 2 is the same. One has different values. Show me a textbook. Okay, they just double the values. Till question 6, you have to finish everything. Okay, your homework is to finish 3 till 6. What is the exercise? 2A, no? 2A. It's your homework. You're all finishing that.
Yes, sir.
Okay. All same formulas, easy questions. Should do it. All right.
What's a good learning skill?
Wait, I'll tell you. Okay, I'll see you all tomorrow. Okay. Bye, everyone.
Bye, sir.
Bye. Okay, question number 3. A man spends 7.4 kilojoules energy in displacing a body by 74 meters in the direction in which he applies the force in 2.5 seconds. Calculate the force applied and the power spent by the man in horsepower. Okay, so force. What is the formula to find force? I'm just doing it the short, I'm not writing every detail that's given there. I'm just explaining what formula to use. Yeah, so the question is to find the force. What is force formula?
Displacement upon time.
Displacement upon time. How's that? Okay, see, we know one formula for force, which is mass into acceleration. Now here there's nothing, there's no mass, there's no acceleration, so we can't use this formula. Which other formula has force in it? Work done. Work is equal to what? Force into displacement, right? Now,
Yes.
so this is the formula we'll have to use. A minute. Okay, so in this formula, what all we have? A man spends this many joules. So joules means that's work. Then displacing a body by 74 meters. So we have the distance and we have to find force. Right. So this is the formula we are using. Make force the subject. So force is equal to what?
Force is equal to displacement upon time.
Force is equal to what? S upon W or options. What is the formula for force? Make force the subject. You want to make force the subject. So keep force over here and you will move S to the other side. See, we need to find F. So keep F. It's already on the numerator here. So leave F over there. Take S on the other side. So S will go in the denominator. So F is equal to W upon S. Right? So W is how much here? Work is 7.4 kilojoules. So kilo means 1000. So 7.4 kilojoules is how many joules? Huh? Kilo means 1000, no? So 7.4 kilos is how much? 7,400 joules.
7,000.
Because kilo is 1000. So to convert 7.4 into joules, you're multiplying with 1000. It's like 7 kgs. In grams is how much? 7,000 grams. Right? The same way. Yeah, so that is 7,400 divided by S. S is the distance, which is 74 meters. 74. That is coming to how much? 100.
100.
Okay. The next one is to find the power. Now, power formula is what? Work done upon time. We have the work done, which is 7,400 divided by the time. How much time? 2.8 seconds. Okay. Now, after you get this answer will be in watts, right? And then you need to convert the watts into horsepower. So, how do you convert watts into horsepower? We saw yesterday that 1 horsepower is how much? 1 HP is 746 watts. Correct? So now what is the conversion from horsepower to watts? What do you have to do? How do you convert horsepower to what? 1 horsepower. To make it what do you have to do? No, I'm saying from horsepower to what? What is the conversion from horsepower to what? Plus, what is 2 horsepower? Yeah. So to convert horsepower to what you have to do into 746. Correct. 2 horsepower means 2 into 746. 3 horsepower means 3 into 746. Right? No? So now here we are converting the opposite. Watt into horsepower. So what do you have to do? divide by 746. So whatever answer you get over here, that answer you'll have to divide it with 746 to convert it into horsepower. Is it clear, everyone? For any conversion, first you write down what you know about it. What we know is, we know that 1 horsepower is 746 watts. Then we have to calculate what to do when we're converting horsepower to watt. So 1, how do we make it 746? By multiplying with 746. So then what do you do the other way? For watts to horsepower? Divide by 6. Okay? Clear how to do it? What's the next one now? Fifth one you have done, someone? Fifth question. How many of you got the fifth question? Where's Ryan and Nathan? Okay, you want to note down anything in the third one? Note down if you haven't gotten it. Then we'll do the fifth one after that. We will go to the fifth one. Those of you who didn't get it, please complete it later on. A machine raises a load of 750 Newton. So what is 750 Newton?
Force.
Force or weight.
Wait.
750 Newton. Just by looking at the unit, you should know what the value is. Okay, so the load is lifted or raised through a height of 16 meters. So what is that? 16 meters in 5 seconds. So what is 16 meters? The height.
Right.
And what is 5 seconds? Time is
Time.
5 seconds. Calculate the energy spent by the machine, energy or work done. So what's the formula? Which formula are we using here?
P power is equal to
Huh? Okay, W equal to F into S, or it's going up against gravity, so mgh. Both can be used, right? I mean, both the formulas are same thing. This F only is mg. Mg means F is equal to m into g. Force is equal to mass into acceleration due to gravity. And S is the height. Yeah? What's the unit of F? Huh? Come on, quickly and loudly you also tell me. What's the unit for force? Newton. What's the unit of mass? Kg. What is the unit of g? Acceleration due to gravity.
meter per second square.
Meter per second square. Or yesterday we saw another unit. Newton per kg. See here. G is equal to Newton per kg. That's another unit for G. You have to know all these things very quickly. Okay, you're in 10th, not in 7th or 8th now, huh? You need to know these units very thoroughly. You should be able to say it in 1 second. Okay, so now we have to use this formula to find energy. So what is the force? Directly they gave the force in Newton.
750 Newton.
So 750 is that force or the mg. The mg itself is 750 into S or H. What is that? 16. Yes, that will give you the energy. You understand? Second part of the question, what is a power? Power, calculate the power of the machine if it is 100% efficient. 100% efficient means there is no loss. You have to worry about that. You have to just find the power. Okay. So power formula is work done upon time. You have the work done that you just now found over here divided by the time, which is 5 seconds. You'll get the power. Okay.
Yes.
Did those of you did not? And how many of you finished it before I explained?
Me.
Harold, Ahmed, Anna.
I.
Ryan, where are you? You're continuously getting disconnected. Did you do any of the homeworks? Having internet problems with you. Nathan, did you do the homework?
third one.
What about 4, 5, 6?
Not the fourth one. The fifth one I just started. Did the third one.
See, if you don't send me the homework, it means you have not done the homework. Okay? Those of you who have not sent me,
We can use even MGH in this question.
what?
We can even use MGH in this question. I used W is equals to F into S, but how to use MGH in this question?
We can't use MGH because we don't have mass, no? See, they've given the mass has to be in kg. Here the mass is directly given in Newton. So, which means they have already given the value of F, the M into G part. The mg is given, like they've already multiplied it with G and given the answer.
So I converted the
You first found mass.
yeah, but I tried, but it didn't come.
With what you do? How did you find the mass? You divided with 9.8 or with 10?
10.
I also tried it with MGH first and then I took it.
So what did you take for M? How 50 you got?
75 things.
Yeah, so you can get 75 into G. What you took for G?
10.
10 into 16. You'd still get the same thing, no?
I realized it.
Because 75 into 10 is 750. You got 5 for height. That's a
And
silly.
then the question also did not give G is equals to 10
Yes,
Newton kg.
exactly. So they didn't give the value of G. So we don't take that 75 into 10 only. We directly have the 750. Like they have solved it halfway for us. Like, they gave you F. So we use that F into the height. Leah, what's the answer?
I got the multiplication as
What, 750 into 16? How it became? 750 into 10 itself is 7,500. Into 16 should be bigger, no? I think you should join the 7-7 batch. You're doing multiplication over there. Today we did division. If you don't know division, multiplication, division. Did you all get the answer? 750 into 16?
Yes, sir. Yes, sir.
And power? So power, for this you'll get 12,000 joules. So power is 12,000 joules divided by the time, that is 5 seconds. That is 2,400 watts. The sixth question. An electric heater of power 3 kilowatt is used for 10 hours. How much energy does it consume? Express your answer in kilowatt hour and in joules. See, these are the two units for energy, kilowatt hour and joules. So you're expressing it in both the ways. Yesterday we saw the conversion between kilowatt hour and joule. How much is 1 kilowatt hour? How many joules?
3.6 into 10 raised to 6 joule.
So how do we convert kilowatt hour into joules? Multiplying with this value. So from joules to kilowatt hour, what you'll have to do? You'll have to divide with this value. Divide by 3.6 into 10 raised to 6. Right, everyone?
Yes, sir.
Okay. So first, what all is given? An electric heater of power. Power is how much, Leah? Tell me in the standard unit. You can't use 3. 3 kilowatt means what? 3000 watt. Kilo is 1000, no? 3 kilowatt means 3000 watt. Time is used for how long? 10 hours. Okay. See, we can use, if we use hours, our answer will come in kilowatt hour or in watt hour. If we use in seconds, our answer will come in joules. So we'll need both. Or we can first find in kilowatt hour and multiply it with 3.6 into 10 raised to 6 to convert it into joules. Okay. So let's take it in hours itself. Once we get our answer, we'll convert that into joules. All right. So time is 10 hours. How much energy does it consume? Energy is equal to, what's the formula? Power into time. That's 3000 into 10. So 30,000 what? Power is in watt and time is in hour. So this answer will be in not kilowatt hour, just watt hour. Right. If we want it in kilowatt hour, we have to divide by 1000. If you divide this with 1000, then you will get 30 kilowatt hour. Remember, with this divide by 1000, we can put it in the formula itself. Here itself, if you put divide by 1000, then your answer energy will come in kilowatt hour. Right? Energy is equal to power into time divided by 1000. A very important formula that you'll be using in this chapter as well as electricity chapter in the future. Energy is equal to power into time divided by 1000. I told this, no? Yeah. Okay. So if you don't divide by 1000, then your answer will come in what? Watt hour. If you divide by 1000, then you will get your answer in kilowatt hour. Okay. Now we also need to find our answer in joule. How do we find our answer in joule? We can do this 30 into what?
3.6 into 10 raised to
This is one way to do it. The second way is here itself, this time we can convert it to seconds. Because if time is in seconds, then your answer energy will be in joules, no? No? Remember this? Only Anna got it. Huh? See, if the time is in hours, come on, this is last class topic. Let me go back. Here, we did all this. So what we saw here, look at this. If power is in watt and time is in hour, then energy is in watt hour. If power is in watt and time is in seconds, then energy is in joules, right? So that is another way to get your answer in joule. Convert your time from hours to seconds. You understand? Or the other way, first way is how? Just to convert kilowatt hour into joules, what you can do? Multiply with 3.6 into 10 raised to 6. So you have two ways to convert kilowatt hour into joules. Is that clear, everyone? Okay, so let's do the normal conversion from kilowatt hour to joule, that is multiplied with 3.6 into 10 raised to 6. So how much is that now? 30 into 3.6 you can do.
1.08 into 10 raised to 8 joule.
But how do you get that? First 30 into 3.6, 6 3s are 80, and here you have 90, 0, 8, 1, 0. Okay, and then put 1 point. So here what we're getting is we're getting 108 into 10 raised to 6. Correct? Now this is not a standard form. A standard form is for this number you should only have one number before the decimal point. Right now for 108 How many numbers are there before the decimal point? Where's the decimal point here? It's here after 8. So before the point, you have how many digits? 3 digits. That's not the standard form. In the standard form, you should only have 1 digit before the decimal point. So which means you need to move this point back by how many places? 2 places. You need the point here, 1.08. So when you move the point backwards, you're making the number bigger or smaller? You're making it smaller. So to balance it out, this 10 raised to 6, you should make it 2 digits bigger.
Yes.
Okay. So if you're making this smaller by 2 digits, then 10 raised to 6, you make it bigger by 2 digits. So it will become 10 raised to 8. This is how we convert to the standard form. Is everyone clear on this?
Yes, sir.
Okay. We'll give you 1 minute to note down whatever has to be noted down here, and then we'll go to the 9th question here. Okay, we'll go to the next question, number 9. Okay, all right. Let's read this. An ox can apply a maximum force of 1000 Newton. It is taking part in a cart race and is able to pull the cart at a constant speed of 30 meters per second while making its best effort. Calculate the power developed by the ox. So what power the ox has, we have to find. All right, tell me what all values are given. Force 1000 Newton. Then speed is given. Speed or velocity. I'll write V because we don't write S because S is used for displacement, right? So velocity is 30 meters per second. Calculate the power. Okay, that's all. 2 values are given, you have to find power. How do we find this now? What's the formula for power? Power is equal to work done upon time. But we don't have work, we don't have time. Then what do we do? Find what? How do we do this now? See, we need work and time. Is there any other formula you know for power? We don't know any other formula for power, right? Or is there? No, there's no other formula. I don't know any other formula. So how do we convert this, or what do we do? We need to derive a formula. We need to make a formula. Okay. So we'll substitute the value of work. What is work? Work formula is F into S. So instead of work, I'll put Fs upon time. Okay. Now we got one thing. See, we got force. See, force we got. We have force. We got force in the formula. But we need velocity. So you have to think now, what is velocity? Is there any relationship between the values in this formula to velocity? What is velocity's formula? Displacement upon time. Do you see displacement upon time in this formula? S upon T. So instead of S upon T, we'll put V over there. So your formula becomes what? F into V. Do you all see that? Are you all understanding me? See, we have to derive a formula like this. First, what we did, in place of W, we wrote F into S. Then second, what we did, in place of S upon T, displacement upon T, we wrote V. And so now we got a new formula, that is P is equal to F into V. And now we can find F is 1000 into V is 30. So we have 30,000. What's the unit? watt, power of finding. Now 30,000 watt is not a very beautiful number to look at, so we can convert this into kilowatt. So 30,000 watt can be written as 30 kilowatt, because 30,000 is 1000 is kilo. Clear, everyone?
Yes, sir.
We'll solve this and rejoin the meeting. I just explain this 14th question once again. Listen very carefully. The last few questions, that is 13, 14, 15, and 16, they all have ratios. You see all the answers, they're in ratios. So whenever you're doing any question in ratio, make the formula in terms of ratios, like derive your formula in the form of a ratio and then substitute the value. So here in the 14th question, they asked you the work done by the boy and the girl. So your formula should be work done by the boy divided by work done of the girl. And then in place of that, you put the formula for work done, which is, now here they're going against gravity, they're going up, climbing steps. So the formula is mgh divided by mgh. So in the formula, you substitute all the values. The main thing about this is, even if the units are not standard units, they just have to be the same unit. Numerator and denominator should have the same unit. That means if height is in centimeter, denominator also height should be in centimeter. If height is in kilometer, denominator also height should be in kilometer. Okay, so that's how we found the ratio between their work done. And for ratio between their power also, we use the formula boy's power, which is work done upon time, divided by the girl's power, which is work done upon time. So in the numerator, you have work done by the boy divided by time taken by the boy. I'm writing B. In the denominator, you have work done by the girl divided by time taken by the girl. So we modified this formula by converting this division into multiplication. So we had to reciprocal the denominator. Work done upon time became time upon work done. And then we just rearrange the denominator. So work done of the boy divided by work done of the girl into time taken by the girl divided by time taken by the boy. Now we already have this ratio which we found in the first question, which is 4 upon 3. So we put 4 upon 3 for that. And for time taken by girl upon time taken by boy, we use 3 minutes upon 4 minutes. See, even though minutes is not the unit that we have to take, it doesn't matter. Because say, even if you convert it to seconds, you will do into 60 here, right? Down also you will do into 60 to convert to seconds. That will anyway get cut, right? And so our answer is 1 divided by 1. Writing it as a ratio, it is 1:1. Okay. Your homework is to complete the rest. That is 13, 14, and 16. Or
Yes, sir.
13, 15, and 16. Okay, so what all questions I gave for homework
13, 15, and 16.
before that?
10 to 16.
10 and 11.
Yes.
Okay, so 10, 11, 13, 15, and 16 is your homework.
Yes.
Now from our book,
Yeah, from your book. It's the same from here also. Okay, this is from your book. This is what? 2A, right? Exercise 2A or numericals 2A.
There is tuition for computer.
Yes, Sunday at 11 o'clock. Computers, okay? All right, as much as possible, no, you should try to come here for tuitions at least. I don't know, Ahmed, Gloria. Gloria, you're coming here, no? Sunday morning? You here?
Yes, sir.
Tomorrow is Saturday night. Where's sleepover? You mean overnight camp? Don't call it sleepover. Sleepover is in your house. Okay, overnight camp you're having. Okay. All right. So then after that, What time that will be done?
Continue with past tense.
Okay. All right. So after that, you come. Okay. Leah, get her and come. All right then. I'll see you all on Sunday. Okay. Bye everyone. Ryan also, please come offline on Sunday. You're there for Pathfinders, no Ryan?
No.
You're not there. Okay. Anyway, if possible, try to come. Okay. You're having a lot of problems.
Okay.
Okay. See you all. Bye.
Hi, sir.
But
Admin records. Okay, so what we are seeing is we are seeing the density of water. The density of water is 10 raised to 3 kg per meter cube, which means 1000 kg for 1 meter cube. In other words, that is 1 gram for 1 centimeter cube. Or in other words, 1 liter of water is 1 kg. Okay, it's for water, it's very simple. 1 liter of water is 1 kg. This bottle in my hand is a 2-liter bottle. So the weight of the water here will be 2 kg. Yes, say it out. Okay, so 20 liters of water will be how much? 20 kg. Okay, so the calculation might become a little complex because you have to convert liters to kg per meter cube, but you need to know it. So let's do that now. We have time now. It's holidays, right? So you need to understand the conversion. How do we get that? Okay, so 1 liter is 1000 ml, right? And 1000 ml is 1000 centimeter cube. This is all units of volume. 1 liter is 1000 ml. And 1000 ml means 1000 centimeter cube. This is something that's equal. 1 ml is 1 centimeter cube. Okay, so 1000 ml is 1000 centimeter cube. Is that clear? Now, what we also know is that since the density, what's the density of water? Take the
10
CGS.
minus 50.
raised to
Yeah, that is the SI unit. Take the CGS unit. 1 gram per centimeter cube. What does that mean? It means 1 gram of water is 1 centimeter cube. This is what it means. 1 gram of water, the volume is 1 centimeter cube.
now
Or
1 gram of water or 1 milliliter of water.
okay, so look here. 1 centimeter, let me write it the other way. 1 centimeter of cube of water is 1 gram. And 1 centimeter cube means 1 ml, no?
Yes.
Because centimeter cube and ml is the same thing. If 1 ml is 1 gram, then 1000 ml is how much?
1000.
1000 gram. That means 1 ml in other unit is 1 liter. And 1000 gram means
1 kg.
1 kg. You understand that? Okay. So 1 liter of water is 1 kg, not 1 liter of milk or 1 liter of mango juice. Okay. 1 liter of water is 1 kg. That depends on the density. Now, suppose you have mercury. Let's take mercury, for example. You know what's the density of mercury? It is around 13.9. I think if I'm not mistaken, it is 13.9 gram per centimeter cube. What does this mean? It means 1 centimeter cube of mercury, only this much, 1 centimeter cube. The weight of that is how much? 13.9 grams. You see the comparison? 1 centimeter cube of water is how much? 1 gram. But the same volume, 1 centimeter cube of mercury is 13.9 gram. What do you understand from this? It's more dense. Mercury is more dense, which means it is more heavier. Okay. Now convert this into ml or liter. 1 ml is 13.9 grams. 1000 ml will be 13,900 grams.
100,000.
That means 1 liter of mercury is how much? 13.9 kg. This is the conversion. 1 liter bottle of mercury will weigh 13.9 kgs. You see, it's much heavier than water. Is that clear, everyone? So only water's 1 liter is 1 kg. Any other substance, 1 liter will not be 1 kg. It will be either more than 1 kg or it will be less than 1 kg. Is everyone clear of this? Just write down this much. Comparison of density of a substance to its mass. After this, we will continue with 16th question. Write down this. Okay, everyone done with this?
Okay.
So, how do we use this over here now? How is this applicable for our question? Yeah, they have given the mass, I mean, they have given the volume of 20 lit, the volume of water, which is 20 liters. So what we know is the mass of water is how much, Aman?
20,
20?
20 kg.
20 kgs. So you just write over there, since density, don't need to write the whole explanation. Since density of water is equal to 1 gram per centimeter cube, therefore 1 liter is equal to 1 kg and 20 liters is equal to 20 kg. So just that one statement should be enough. Okay. Then you write this explanation here. I mean, apply the values in the formula. That's 20 into G. What is G? Is it given? Here, G is given as 9.8 into height. What's the height? 20 meters. Okay. Divided by the fathers. Now, father is lifting how many liters of water? Same, 20 liters. Acceleration is the I mean, G is the same. And what is the height? Same. The same, right? Both are doing the exact same amount of work. So everything will get cut off and you'll get the ratio 1:1. So work done, the ratio of their work is 1:1. Clear, everyone? Now, what is different for both of them? Their work done is same. The power is different. Now, who takes a lesser time to do the work? Father does it in 2 minutes. The boy takes 3 minutes. So who has more power here? Father has more power. Okay, so that's what we're going to find next. So the formula, power of the boy divided by power of father. Now what's the formula for power? Work done upon,
Work upon time.
and here also work done upon time. Remember how we modified this formula in the last class? Okay, see now work done of, I'm putting B over here. Work done of boy, time of boy. Work done of father, time of father. So how do we modify this formula? Work done of boy divided by time taken by boy. And this middle division will convert that into multiplication. So what will it become? Into
Time taken by father upon
taken by father.
work done by
Work done by father. Then we can just interchange these two and we'll get what? Work done of the boy divided by work done of the father is equal to time taken by father divided by time taken by boy. Multiplication over here. So now we have the value for work done.
we can
of the-
just interchange like that. We don't need to check anything for interchange.
Yeah, we can interchange because it's multiplication in between. So any order you do the multiplication, it will be the same. All right, so that's 1/1 into time taken by father upon time taken by boy. So time taken by father is how much? 2 minutes. Time taken by boy is 3 minutes. We don't have to convert it into seconds by doing into 60 into 60 because it will anyway get cut off, right? Anyway, so your answer, the ratio of their power is 2 is. Okay, write down this much. Don't copy, try solving it.
I got it here, but only the B part I didn't know.
Okay, for those of you who didn't get, you can write this. Anyone has any doubt, please ask. Sneha, you understood how we did this? I mean, I have not explained all this to you because you missed those classes, but this is the formula and this is how we're substituting it. Are you understanding?
Yes, sir.
Okay. Who left the class? Huh? Ahmed. Okay, we'll go to the last part. Those of you who didn't finish, please copy that later on. The last part, the B part of the question is how much work each does. Now we know that already both of them are doing the same amount of work. So we just need to find the work done by either the father or the boy. So again, work done formula is what? F into S or MGH. So what should we use here? We'll use MGH because we have the mass in kg. What is the mass? The mass of the water is 20, no?
20 kg.
20 kg. The value for G, acceleration due to gravity, is given as 9.8. The unit is either meter per second square or Newton per kg. And then the height, 20 meters. Yeah. So we put these values. That's 20 into 9.8 into 20. All right. So that's 9.8 into 4. How much is that? 2 to the 4. 9.8 into 4 is 39.2. So 39.2 into 2 zeros. That's 0 and 0. So that is 39200 joules. If you're writing this as kilojoules, you need to divide it by 1000.
I think it should be 39202.
Oh, sorry, I made a mistake. Yeah, 3920 joules. Because into 100 means the point goes run by 2 places. Yeah, and then if you're writing this as kilojoules, then you divide this by 1000. So 3920 divided by 1000 will be in kilojoules.
3.92.
Yeah, 3.92 kilojoules. Clear, everyone? Your homework will be to complete the rest of the numericals in this chapter. Okay, you have to sit and solve everything. You have to solve the whole textbook and many other textbooks before your board exam. Okay, not just a few questions from here and there. That's your work and your aim for your 10th standard exam. So solve everything else that's remaining. We will do the B part in the next class. Okay, all right. Write down whatever has to be written down. Those of you finished, I'll see you in the next class tomorrow. Okay, bye everyone.